Let's see how the Euclid's division algorithm work. So Euclid's division algorithm actually can be used to find the HCF of a number. So let's work around how this algorithm actually works. So let us take an example of let's say a number 225 and 135. These are just random numbers which I'm taking. So let's see how can I find the HCF of these two numbers using the Euclid's algorithm. So the algorithm first of all says uh, try to uh, like 135 here being the smaller number, try to divide this number with the other one and see if this number completely divides 225, which will mean that 135 probably would be a factor of 225, and in case in this case it would be the highest common factor, as uh, it couldn't be anything bigger than 135, because any number bigger than 135 would obviously not be a common factor for 135. Here we are looking for a common factor which divides both of these numbers. So let's start with this. So I will just divide 225 with 135. Let's see how it goes. I think it will only go on 1. So it would be 5 minus 5, 0, and this will give me 9. So 90 would be the remainder here. So yeah, 90 is the remainder, right? Correct. So now what I'll be doing here is, instead of worrying about these two big numbers, now I will just apply the same rule which we applied here to 135, which is the smaller of these numbers, or which was the divisor in this case, and the remainder, so 90. So now I have actually narrowed down my problem to a smaller number, which is 135 and 90. So what now we are going to do is just like repeat what we did here. So now I will try to find out if I can completely divide 135 by 90. So just do that basic division. So I write 135 here, 90 here, and let's say 2 would be 180, which is bigger, so this also goes at 1. I have 90 here, the remainder would be 5, and 13 minus 9 would give me 4, right? So yeah, now I have a new remainder here, which is 45, and we just you can like observe, we are having a recursion here. We are recurring our steps, which uh, we basically are recurring our steps here. So now I will take this 90 over here, and the new number which I received is the remainder by dividing these two numbers, which is 45. And now here we can clearly see 45 times 2 is 90, correct? Which means 45 is actually is actually a common factor for 90. So for this problem here, just ignore those part, only focus on this one. So for this, the common factor for 90 and 45 is actually 45, and to our surprise 45 is also the HCF for 135 and 90, and yet again it is also a common factor and actually the highest common factor for these two numbers. You can verify this by any other method which you are aware of, but this 45 is actually my answer for this. So this is pretty much the algorithm, the Euclid division algorithm. That's how it works. So let's try to figure out a systematic algorithm form of it, like how to create an algorithm for a computer to work. So let's say I have two variables A and B. I receive a user input here. So the values to these two variables, most preferably integers of type. So user gives a value to A and B. Let's suppose I have here I have a function HCF which takes A and B as its parameters, and now our first, what should be our first condition? We actually all if we are creating this, let's assume a situation that A should always be bigger than B. So if A is greater than B, this is our first condition here. Then one more if A modulo B. I think everyone is already aware of what a modulo operator do. It simply gives the remainder when we divide A and B. So A modulo B, if it is equal to 0, in that case, what would happen in that case? In that case, B is actually our HCF. So we can simply print B. This is just a pseudo code. I am actually not following any specific language over here. It's just a representation of the algorithm in a pseudo code form. So what my algorithm says is, if out of these two user inputs, if A is greater than B, and yet again if A modulo B is equal to 0, meaning this gives us an output of 0, which means that if I am dividing A by B, I am getting a remainder of 0 over here, then this B is the HCF. So simply print it. Else, oh sorry, I misspelled else. So yeah, so if this all thing is not true, then what should happen? In that case, what I just want is, I actually want to do recursion over here and do a recursion of B and A modulo B. So if you can if you are able to understand here, what will happen is that if A and B gives a remainder 0, that means we have achieved a condition which, if you remember, there was when I divided 90 by 45. So in this condition I was getting a remainder 0 in the previous example, right? So this is actually our exit statement in this program, right? Uh, so if that's not true, what I just want is that I want to use B, which because of this statement is the smaller of these two numbers, right? So I want that B and also the remainder of A and B. That's what we actually want. So now this function will recursively try to solve it until we get a situation where actually a modulo b is 0. If we are giving it some number where there is actually no common factor which satisfies this condition, still there would be 1, because we know from our earlier knowledge that 1 is a common factor for every number, right? So that's where it will end in that case. So that's pretty much it. Now we have completed this part. Now let's think of this problem over here. So if A is greater than B, then do this whole thing. What if B is greater than A? In that case, I'm using an else over here. So this goes like this. Else, what I want to do is do the HCF of B comma A. We are just reversing those numbers. We are making it suitable to again start from here where this condition is true. So that's how you will design an algorithm for taking out an HCF using Euclid's division method.
All right. So now, as we have already seen how the algorithm works, let us now actually see how we can program the same. Let's create a C program for that algorithm. So I am gonna start with some simple headers. So I will hash include standard IO so that I can use the print function. Now I will create actually of a type void a function whose name is HCF, and it takes two parameters, uh, first being int A and int B. So this is actually the prototype of my function. This will basically tell my compiler that just wait for me. I have a function named HCF somewhere down in my program, even if it's below my main function. Now, I will create my main function, int main, parameters being void over here. And now, what should my main function do? First of all, it should have two inputs, so basically two variables, A and B, which can be used to take the inputs. So let's write a simple print statement saying enter first number, and then I will use scanf to capture an integer and store it in my variable A, and then I will just repeat it for taking the second number, and I will use scanf again to store my number in the variable b. And after that, once I have taken an input for both these numbers, I just want to feed these numbers in my function. So HCF a comma b. Now I think that is pretty much it, and at the end, because it is my main function is of type int, so I would return 0. That's pretty much it for the main function. Now let's create our actual function, the star of the show, which is the HCF, and this will take int a and int b. And also, like, we can use any variables in this. It doesn't matter that these a and b should be equal to what we have taken in our main function. They can pretty much vary. It's just for convenience that I have written them the same. So now, what should my this HCF function should do is, first of all, I need to make sure that my A is always greater than B. I want my first number to be greater than the second one while doing while taking the HCF. So now I have an if condition where A is greater than B. If that's the condition, then, or again, I want one more condition, that if A modulo B is equal to 0. If that's the condition, I just want to print whatever is the value of B. Yeah, that's pretty much what I want to do here. But if that's not the condition, like if A modulo B is not equal to 0, then what should my function do is, you should just call yourself again, and this time the parameters should be B and whatever is the result of A modulo B. So that's what I want this time. Also, like, just to make it more user friendly, let's just write the HCF is this number. So this is actually our main function, which is doing all the hard work. And we also will consider a condition where A is not equal to B. So what should I do in that case? So I can simply call my HCF function again recursively, and this time I'm just saying, just swap these numbers. Instead of using A comma B, use B comma A, because it doesn't matter whatever the number is, we just want these numbers to be in a right orientation, that the bigger number is getting divided from the smaller, or the smaller is always the divisor, else the division would like not happen the way we want. So I think this is pretty much what our function is doing. So let's try to run it. My fingers are crossed, and let's see if this compiles well. And it does. Okay, so it's asking me to enter my first number. Let's take that example only where we know the result. So my first number would be 225. Why didn't it ask me for the second number? Oh God. I think I have uh, made some mistake here. I don't know. 225. Ask me for the number, damn it. I don't know what's wrong here. 225. And now it's I don't know what happened, but now it's working. So let's enter the second number. And yeah, within a fraction of a second, it gave me the HCF 45. Let's just try to reverse these numbers and see if this segment of my program works. So I will run it again, but this time my first number would be 135 and the other one would be 225. And see again, the HCF is 45. So this basically shows that everything is working fine, and that's how you create a function for taking the HCF of two numbers using the Euclid's algorithm. That's all.